Is it 7? Oh, I was like, what? We've been that far? I don't know. I don't know. However many we get through, whatever we get to here, then when I get you in pre-cal, I'll just pick up there. That's the good thing about whenever I teach it through, I teach them all. Do what? If I include what they're all talking. Oh, really? I thought we were more than that. We got bogged down in that quadratic unit. All right, here we go. Nth roots. Let me review for just a minute about what is this? Square root. Tell me if you were explaining to someone who had never seen this in their entire life how you do a square root. Tell me what you would tell them. A number times itself. Times itself how many times? Twice. So would it make sense to you? Have y'all seen this before, by the way? No, nth roots. Yeah. Would it make sense to you if I said then that there was, in math we always have these little imaginary or implied things. There's an imaginary 1 in front of a number. If there's nothing there, there's always an exponent of 1, those kind of things. Would it make sense to you if I told you there was an imaginary 2 that sat here super small like that? Would it make sense to you as to why that's a 2? Multiplied by itself twice. Okay? That's a square root. I can change that little teeny baby 2 to any number I want. Maybe I change it to a 3. And be careful when you write this because this is not the same as this. Okay, so make sure it kind of sits in there, almost like that's this little chair, and it just sits there. But I could change it to any number I want, and then it becomes what number times itself 3 times gives you that value. So you know a lot of cubes. What if I said the cubed root of 8? 2, right? What number times itself 3 times gives you 8? What can you never have with a square root? A negative under the square root, right? You can, but it's imaginary. But in cube roots, you can. Why could I have it in cube roots, but I could? It's odd. It's odd. You're exactly right. Because negative 2 times negative 2 times negative 2 would give me negative 8 because I got a positive, then a negative, right? So it's negative. Does that make sense to everybody? What's that equal? All the properties of radicals still apply. Negative 1/3. Because what times itself 3 times? And I could split it up. I can do the cube root of the top and the cube root of the bottom. So I get negative 1/3. Is everybody okay? Just blowing anybody's minds? The fraction did. So I could make this the cubed root of negative 1 over the cubed root of 27 and then do each one individually. Properties of remember those 2 properties of radicals? Well, I'm still going to put it because you asked. Those properties still apply even though they're different roots. How about that one? Why did I throw a plus or minus there? It's an even root, okay? 3 times 3 times 3 times 3 is 81, and 2 times 2 times 2 times 2 is 16. in the plus or minus because it's even. So let's make a general statement here. Even roots, you got to have positive. Under the radical. And they get a plus or minus on the answer. Odd roots don't get a plus or minus because they can't be either one. They just keep their sign. The radical. I give you a second now. Copy that. Let's see. Let's go back a bit. What can you do there? You can probably pull something out. It's not a perfect square, right? But I start looking for perfect squares that I can take out of that. Anybody got any ideas? Boy, y'all are asleep today. Noah, you're literally asleep. 9 and what? But what if it's not square root? What if it's... Yep. So that's what we did before. Now let's do the new stuff that works just like it. This time, I'm looking for a power of 3 to divide by instead of a power of 2, right? Would you? You tell me. So if you get confused, start thinking, all right, this number is 3, right? So what are powers of 3? 2 to the third is 8. 3 to the third is 27. 4 to the third is 64. It's not going to be that big. Can I divide that by any of those? And the answer is yes. I can divide it by 8 and be left with 6. So now I got 2. What's the cube root of 8? 2. Remember, this is multiply. 2 times 2. You see, nothing else has changed. I'm doing everything the same way. It just might be that that root is different. No plus or minus because odd roots keep the sign of what's there. Yeah.
So if you were to have a negative root, would you pull that negative out and put it in front of the negative root? Or put it in front of the negative root?
Yeah. One more, and then I'll do the last thing with variables. See if you can do this one. Simplify this one. Sure. Anybody get it? What's the perfect 4? What is it? 6 to the 4th. What is 6 to the 4th? And what's left? 2? Because it's an even root, right? Everybody okay? Speak now, forever hold your peace. This is a pretty easy lesson for us today. What if we have variables in here? Any idea how to simplify that?
Minus 4 x squared y
All right, let me show you what you do. You're right on this. The 32 I can split up, right? 16 and 2. Which gives me 4 times the square root of 2, but I still got, under the square root, I still have x to the 4th and y to the 9th. So here's what we do. This is where it gets a little confusing. This is the easiest way I know to tell you to do it. This is the way my brain works. Divide the exponents by the root. This is for variables, by the way. The whole number that it goes into goes outside. And I think this might not make sense as I write it, but hopefully when you put it alongside the example, it'll make sense. And the remainder stays inside. In other words, the root here is 2. We all agree with that? All right, so I've got 4 square root 2. Now, if I break this up, 2 goes into 4 how many times? How many times 2 go into 4? What's 4 divided by 2? 2. So x2 goes on the outside. There's no remainder, so I don't have to worry about it. Now do the same thing with the 9. 2 goes into 9 how many times? 4. How many's left? 1. Great day. Now I can put it all together. I have 4x squared y4, and I can put what's under the square root together. And on these, you don't have to worry about pluses or minuses with the variables. Does that make sense? A little bit? Is that?
Yeah, I said that out loud.
Uno más. Simplify that one.
Dude, my calf hurts so.
Did y'all get it? No. All right. How about this one? How about the 625? It's just 5, right? How we get what? No, this one came out even. It might not come out even, and you have to, like this one over here, that we have to say what breaks down. Which one of that power goes in evenly? How many times does 4 go into 23? 5 times. So C5, and it leaves me with how many? 3. 4 goes into 11 how many times? 2, and it leaves me how many?